This is the asynchronous makeup session for Chapter 5, Providing Network Services. And let's start the slideshow now. So this first part of Chapter 5 will talk about how clients and servers work together. I've used this phrase before. Clients request services and servers fulfill those services back to the clients. Then we'll look at internet protocols, a little bit more of the dreaded, feared, and hated TCP/IP layer. And then we'll look at some application protocols and services, because typically when someone in a client machine like your Windows 10 Pro workstation machine, as a student or personal or employee machine, you would typically connect to a server that would provide you back some sort of client server application. So first of all, how clients and servers work together. So there's lots of different servers on the internet and in companies that provide like financial transactions. If you're a banking customer, or if you're an Apple customer, you might download music to your Apple iMusic type thing. Many websites, email services. So what happens is when you click that button, you started a flow of information going. When you clicked on that link to go to that website, you started the flow of information going. You send a request to a particular server. In the case of going to a website, you made the request from give me your home page, or give me that link that I clicked on to that server, and that server, typically listening on port number 80 for a well-known web server, would come back and respond to your request and send, for example, some document back that you clicked on. In web stuff, we have this thing called the Uniform Resource Locator, or URL, which totally specifies the entire server and where you want to go to. Now, some web browsers don't require you to type all of this in. For example, you could just type example.com and it would go to the website, the fake website example.com. You don't have to type the http:// index.com. If you just type example.com, you're going to get the landing page, the home page, the index page, the starting page, the splash page for that particular website. Let me say that example.com is a special reserved name that doesn't exist on the real internet. It's used for documentation and training. So the URL typically specifies the protocol. In this case, the pencil. Can I do pencil? So this part is the protocol, HTTP, Hypertext Transfer Protocol. This is the protocol that specifies that actually transfers elements of a web server to your web browser client while you read it. The next part would be the actual domain name. So Cisco.com, Netacad.com, Microsoft.com, Facebook.com, whatever company or server you're going to would be this. And then if you didn't want just their home page, it would go to, for example, it could go to a folder that said technical support. And they could go to a file folder that said product 1000, and it would get the technical support files for product 1000 of this rack mount server and manufacturer, whatever the particular company was offering up. So here's some common protocols. I like to call DNS the directory information operator of the internet. We can't require all of our users to type in 32-bit or 128-bit IP addresses. It's just too cumbersome for them. So what we do is we give them easy to use names like Netacad.com or Microsoft.com. And when we type those into a web browser, for example, the DNS service would request, well, what is that actual? I can't put Facebook.com in the header of the packet. It's got to be the IP address, the 32-bit binary IP address for Facebook.com if I want to send the Facebook server my login request. So the DNS system resolves that name and replaces it with the actual 32-bit IP address, or maybe an IPv6 address, and then you can connect to it. Secure shell. This is we had another protocol called Telnet that was didn't encrypt the data. So you could anybody could use a easily available program like Wireshark, and they could use Wireshark and sniff the packets, and you could see your name and password right there in the packet in clear text form because it hasn't been encrypted at all. So we use Telnet generally inside labs, stuff that we control. In the real world, you probably would want to use Secure Shell. This is the equivalent of Hypertext Transfer Protocol Secure when you go to the bank site and put in your banking information. You go to Amazon, you put your credit card number in, you buy something. that credit card number gets encrypted so that no one can use your credit card number and buy other stuff and try to make you pay for it. So secure shell is like Telnet. It's a way to get to the command prompt of another device, typically a router or a switch or a server, some type of network device. But it encrypts everything using a public and private key pair. We'll talk more about security in the next chapter. So we can get remote access to servers and networking devices like routers and switches. Okay, simple mail transfer protocol. If you use an old style mail program like Eudora, most of the traditional email programs have been replaced by web-based email programs. So like the email that we give you, your Tarrant County College student email, first name, last name at my.tccd.edu. That's using a hosted Google Mail service thing. Everybody's but sneak preview. You guys are all getting switched in about a year to Microsoft Outlook Express, the Microsoft version of that. We're going to all Microsoft, but it'll be seamless to you guys, we promise. So the old style mail programs would use this protocol, simple mail transfer protocol, whenever you transfer an email. When you click send, this is what would be invoked, and it would send the email on its step-by-step relay passage until it gets to the inbox of the person you're trying to send email to. The two ways of picking up the email, if it's to you, if it's from you, you type this and it sent the mail. If it's to you, you're going to pick it up in your traditional email program, not a web-based program like Gmail or one of these other type ones where it's a web-based interface that looks like an email program to you. Post office protocol is used to pick up and retrieve email, and IMAP is a more one that picks it up. Post office protocol makes you, when you pull it down to your computer, it's copied and to your computer and it's deleted from your cable company's server, whoever you got your email with. IMAP is a little bit different. You can copy it to a laptop computer and it's retained at the ISP, and you can go maybe to another computer like a desktop computer. You can still see your email. Dynamic host configuration protocol. This is a mechanism that when we don't statically assign IP addresses, sometimes in Cisco labs we statically assign addresses just because we want to get used to the concept of IP addressing and IP services. But dynamic host configuration protocol automatically takes a pre-approved list of possible valid IP addresses that anyone on that little network and that company, corner of that company, could want to use, and automatically gives one to everybody when they boot up their computer. So automatically configures devices. We don't have to statically configure. Well, I used to work at a company in the 90s with about 200 people in the offices, and I would have to statically configure over 200 network devices because there was a computer for every person, but plus some printers and stuff like that. It was over 200 devices. So DHCP does this automatically. Your home router uses DHCP and gives your IP addresses to all your local devices at home, typically 192.168.1. something, or maybe 192.168.100. something. A web server is something that's typically not on your home computer, your employee computer. It's typically at a data server somewhere. A web server is where all the pages that make up the web presence for that particular company, like Cisco.com's got a big web server that has all the files they go when you log on to Cisco and buy routers and switches and go to their tech support department. These are typically not Microsoft Windows 10 computers, but rather are going to be some type of server computer like Windows Server 2016 or Windows Server 2019 or Linux or something like that that typically runs these servers. Okay, let's look at some protocols. Now we talked last time, compared to the dreaded, feared, and hated OSI 7-layer reference model, and then we went down to the TCP/IP model, which is the actual model of the internet that we've been using now, a de facto model. And when we looked at these protocols, we talked about these application layer protocols like hypertext transfer protocol and domain name and so forth. And those are the things that are running at the application layer. They're actually talking to the application programs you're running, like email program that wants to print something, or a web browser that wants to contact a server somewhere over the internet and send packets to it. So these application layer protocols are written to work with various types of application layer programs. So when we go down from the application layer program and they generate, say, a web request that says, give me your home page, cisco.com, that's going to go down still in the memory and software operating system of your computer you're sitting at. It will go down to the transport layer protocol, and he will begin to prepare that request to be transmitted over a network. He's going to decide, he's going to divide it up into, if it's too big to be sent at once, he'll divide it up into appropriately smaller pieces. He'll number or sequence them so they can be put back together again. He'll check for, make sure that all the little pieces have been received by the receiving end and acknowledged properly, that there was no errors, and then he'll send the answer back up. And then once these are broken up, and let's say this request was broken up to like 3 little requests because it was too big for one, the IP layer will actually put it in 3 little IP packets, and then that will shoot out of your network card to the rest of the network, and the routers and switches will choose the best path, and your packet will be delivered to the server that you talk to, like Cisco.com, and then his answer will come back, and you'll be able to view that on your PC. It'll come back in reverse. So port numbers are used at the transport layer. This is where TCP and UDP live. TCP is the one that's positive acknowledgement and retransmission, keeps track of everything. UDP is for a quick and dirty thing, like a quick Mr. DNS server, what's the IP address for Cisco.com? And doesn't record all the extra setup stuff and overhead that TCP does. So these port numbers, these so-called well-known port numbers, port number 80 for web data. All web servers listen on port 80 for incoming requests to see their web page. All POP3 mail servers are listening on 110 to pick up the email from their email server at their cable company that they subscribe to. So the numbers below 1,000 or so they're characterized as well-known, and you can't use them, only servers can use them. When you need the source of information, like a request to use that server, you use a high numbered port number, something above 1,000. These are private numbers. There's a class called registered numbers. If you want to, I'll give you an example. I actually work with IBM, makes a database server called DB2. And the company I was working for, we produced a version of our software that was a database application, and we ported it over to DB2. And IBM DB2 has got a couple of port numbers they registered to use with their database product. So when you send requests and acknowledgments back and forth from an IBM database server, use that particular registered port number value. So the source port number, this throws people usually. The source port number is dynamically generated by the sending device. That's your desktop PC. When you click on Cisco.com in your web browser, you're dynamically generating at a high source port number. You can't use port 80. You're not a server. You're only a client. So you dynamically generate a high port number like 1,234, something like that. And then you put that in your source port number. And then when the server answers you back, he'll say, well, I'm the server. I'm sourcing the answer to you back on port 80. And what's that destination port? Oh, that's the port on your machine. You're the destination. Now I'm sending the answer back to you. Oh, yeah, port 1234. And then make sure that it gets it properly. Now, some application protocols and services. Okay, so DNS is the information directory operator of the internet. And it is a distributed system. There's about 14 master DNS servers situated around the globe so that no matter what kind of floods or anything that happens, there's always going to be some of them that still survive. And they have the master list of all of the websites on the internet by their names. So when you go to an internet service provider company, like say you want to rent a web server at a web hosting provider service, you can get your own personal website, for $10 a month or something like that. Or you can go to wix.com, wx.com, you get one for free, has a little advertising. And then you'll make up a name for that website. You have to pay extra for the name, by the way. And then once you pay for that DNS name, it will be sent into the 14 master root servers, and within an hour or so, you will be accessible from the entire universe of the world by that well-known name. Whatever name you made up, mywonderfulnewcompany.com, whatever name you got that hadn't been taken yet, because all the good names have been taken yet. So when you clicked on that one, the guy in the purple here, so the guy in the purple here clicks on and types Cisco. The DNS server responded and looked up what's the 32-bit IP address for Cisco. The DNS server gave that answer back to him, and then his desktop PC created the packet with that destination address, not Cisco. It has to be the number, the actual number of that. So it's not like, some of you guys have these smartphones where you pick it up and you say, call Bob. And voice recognition knows that Bob's phone number is 817-123-4567, and he dials it for you. That's kind of like what DNS does. DNS says, oh, bob.com. I'm going to look up that number. And he looks up the number and he types it in there for you. So web client machines, when they want to look up and go to a web server, they ask port 80 of that web server to give them back his homepage. Now, there are other, typically on these servers, here's our web server here. It might be running other servers besides web servers. It could be running a mail server, could be running a database server, could be running file and print services for the people on that network. So we use the unique port number 80 to get the attention of the web server application that's running on that particular machine. We don't want to talk to the mail server, that's port 25. Then the hypertext markup language, HTML, that's kind of like a macro text format encoding scheme. Think of a Microsoft Word format or something like that. That's the layout for how web pages appear. The idea was no matter what kind of computer you're on, whatever operating system you're using, the layout would look the same. So hypertext markup language is, I call it has too many links. It's a joke. That tells how to format the data. So you should be able to use whatever, when the graphic content creator created that web page to appear that certain way with those colors and web fonts and so forth, it will appear the same way to you no matter what kind of computer you use. So it's a standard, open standard. All the vendors support it. Okay, file transfer protocol is a method that was preceding the web. This was a way of going to a manufacturer that made software and maybe downloading a new version of a software update or a bug fix. So FTP is actually built into most web browsers today. This is a way, this transfers files from one folder to another folder. It transfers a file from a folder or a subdirectory that's on the server drive to the downloads directory of your PC. Now, normally when we log into FTP, we can only download files, and it's kind of a read-only service. We can't put new files up on there. We would go to maybe ftp.microsoft.com, and we would be able to download Service Pack 4 for Windows NT 4.0 or some sort of product like that. It uses, this is the one weird bird thing about FTP, it uses 2 port numbers. It uses 1 port number to actually transfer the data, like the contents of the file, and then it uses another port channel communication as a sort of a command and control. Every other application layer protocol seems to be able to find a 1 port number, but this is a really old one, so it's a kind of weird in that it uses 2 ports. Okay, virtual terminals are what we use to talk to a device. Like, let's say I'm the authorized network technician, and I'm trying to talk to, this is Cisco router here, and it's back in the rack somewhere, back in the data center somewhere. So I've secured it with some public-private key pairs. It's encrypted. Nobody else can break into it. So in this case, the hacker who's trying to break into it, he doesn't have this proper secret key. He's not going to be able to get into the server and mess it up, or even see what I'm in the router and see what I'm doing with it. So Secure Shell uses the public-private key pair scheme, which everything is encrypted, and if you use a long enough key, it's very difficult to break it before the guy is finished with it, or in years. Now, Telnet was the older standard that, when you use Telnet, it was completely unencrypted, and a hacker could run a program like Wireshark, and they could listen to all the packets and decode them, and they could see your name, they could see your login password, and see everything that you do, and it's completely unencrypted. By the way, the FTP program that we just talked about last slide, it's got the same security violation. It's totally unencrypted. So if you want to send files that are encrypted or log into devices that are encrypted, don't use Telnet, use Secure Shell. Don't use plain old FTP. There's a version of Secure FTP that you can use that uses encryption keys and makes it safe. Okay, email clients and servers. In the legacy world, we had separate email clients and servers, and people would use a legacy email program on their PC like Eudora, or some other type of program that can send and receive email. These days, most people are using a web-based, like Google Mail or Yahoo Mail, or what's the Microsoft one called? Hotmail. They usually, and it gives you the same email functionality, but you just see a web-based interface. You just go to a certain web page, like mail.yahoo.com, and you use that. So behind the scenes at that service center, they're doing the SMTP to send your email to the recipient, and they're using the equivalent of IMAP to receive the stuff back. You can log into your email account from any computer and see the same mail on lots of different computers. It doesn't erase the mail like the old POP did. Instant messaging is a application that allows you to log in with a username and password, and then you can send text messages, also maybe sometimes transfer files. And the internet phone calls, Skype and some of these other type of technologies, they make phone calls and maybe even phone calls with video possible, and you can send it anywhere you've got an internet connection, any type of network connection. And I think that's it. Okay. All right, good deal. That concludes this chapter 5. And the next two, we're going to look at chapter 6 and 7, and we're going to look at security things like encryption and decryption that I started touching on here.